In this video, we will talk about measurement scales. Measurement scales are very important because they determine what we can do with our data, what operations are permissible on the values of our variables. So what kinds of operations are we talking about? Well, the first one has to do with equality. Can we say that two values are the same or different? Or identity, in other words. This is something we can always do. The second possible operation is ranking. Can we say that some values are greater than others, or better than others, or in some sense there is a natural ordering among possible values of our variable? The third operation is essentially subtraction, so that we can find out if there are distances between values. Can we say that there are meaningful differences between values of our variables? And the final operation is ratio or division. And that has to do with whether we can say that there is a natural zero in the scale of our variable. Now let us look at some examples in order to understand how this works and what it actually means. Let's start with the simplest example, which is the sex variable we talked about before, which admits two values, female or male. So if you have a bunch of participants, you can measure them for this variable and assign each one a value of either male or female. So the first question is, can we talk about equality? Can we say that two people have the same sex? And of course, yes, we can say that. That's always possible. Every pair of values can be checked for being the same or different. What about rank? Can we say that one value is better than the other, or that is more than the other? I know some of you might have an opinion about that, but the answer is that there is no natural order in these values. They're just two different labels. So there is no rank here. There is no possibility of ranking, which also implies that there cannot be any distances or ratios. The only thing we can do with sex values is check if they're the same or different. And this is called a nominal scale of measurement. What about a variable of education? Actually, level of education, admitting these values as they're used in the Norwegian system. So every person would have one of these values in their educational level variable measurement. Can we say that two people are equal in educational level? That would amount to checking if they have the same value or not. Of course, we can do that. Can we say that there is ranking? Is there a natural order in these labels such that we can always say for two people if one has more or less education, or maybe higher or lower level of education more appropriately? Is there a natural order in these levels? The answer is yes, there is one from lowest to highest level of education. So the answer is yes for rank. What about distance? Can we say that someone who has, for example, ungdomsskole educational level is as different from someone who has only barneskole as from someone who has videregående? Does this make any sense? Can we subtract levels of education to find their distance? We can't do that. That would make no sense. We can only say if someone has more or less than another. So if there's no distance, there is no possibility for ratios either. And this is called an ordinal level scale of measurement. Our next example is birth year. So this is the variable in which we measure someone and assign the value by the year they were born. Okay, can we say that two people were born in the same year? Of course we can. Can we say that someone was born before or after another, or previous or later, earlier or later than another? Yes, we can always say that, and birth years are actually ranked. There is an order in birth years. Okay, how about distance? Can we talk about differences in birth year? Actually, we can. We can subtract the years, and the difference is how many years someone is older or younger than another. So there is meaningful distance, and we can derive that by subtracting. That makes a lot of sense. What about ratio? Can we say that someone born in the year 2000 is born in twice the year of someone born in 1000? Can we say that someone born in 2100 is born in 5% more birth year than someone born in year 2000? Did that sound fairly stupid? Yes, it did. This makes no sense. We cannot compute ratios of birth years because this makes no sense. This kind of variable is called an interval level variable. And what about height? We can measure height in centimeters for our participants. Can we say that two people are equally tall, have the same height? Yes, of course we can. Is there a natural order? Can we always say if someone is taller or shorter than someone else? Yes, this does make sense. Can we compute distances? Yes, we can always subtract two heights and say how many centimeters someone is taller or shorter than someone else. Can we also divide to compute ratios? Does it make sense to say that someone who's 2 meters tall is twice as tall as someone who is 1 meter tall? Actually, that sounds reasonable. Can we say that someone who is 1 meter, 110 centimeters is 10% taller than someone who is only 100 centimeters? That makes sense as well. We can do that with heights. So there are ratios, and therefore this is a ratio level scale of measurement. Let's look at this last bit a little more carefully to understand the difference between interval and ratio. And it all has to do with the meaning of zero. So essentially, when you have variables that are measured with numbers, there are two possibilities. One possibility is to be like birth year or temperature. And the other possibility is to be like height or rainfall. What is the difference between these? Well, in height and rainfall, zero means something very specific. It means there is no quantity of that variable. So zero rainfall means it didn't rain. There was no water in the measuring vessel. Zero height means at the ground. Although you can't expect this to ever happen for a person because nobody has zero height, zero height does mean something. So it's not about whether it happens, it's about whether it's meaningful. So you can, zero height means something, zero weight means something, zero rainfall means something. And it means that there is no quantity of the sort we are measuring. That's what a meaningful zero refers to. What about temperature or year? Well, zero there isn't meaningful. It is an arbitrary point that someone just decided to use so we can use the differences from it for the measurement. And that's why you can have different ones. So for year of birth, the zero is not the same for every culture. We have our zero, that is now called Common Era, and others have different starting points for their calendars. And in temperature, the Celsius scale of temperature that we're all used to here in Europe has the zero set at the freezing point of water. But, you know, in the United States, they still use the Fahrenheit, which has the zero somewhere else. I don't know what made them put zero there. But the point is, if you're supposed to say it's twice as temperature as another temperature, that should hold regardless of the scale, right? Like in height, whether you measure it in centimeters or inches, a person will be twice as tall as someone else. If you're twice as tall in centimeters, you're going to be twice as tall in inches. But if you're twice as hot in Celsius, you're not going to be twice as hot in Fahrenheit, which means that saying twice as hot makes no sense. So the scale itself doesn't have a meaningful zero because zero doesn't mean no temperature. It's just one point along this line. So that's what makes this an interval scale, and this is a ratio scale. And it doesn't have anything to do with having or not having negative values, because in the previous examples that I used, height and rainfall can only go up, but temperature can go, and birth year can go below zero. But that's not what's important. So you can have, for example, negative floor. If you have a variable of floor, like what floor is your office on? In a system where you code ground floor with 0, one floor above ground is 1, 2 above is 2, and first basement being -1, second basement being -2, and so on, which is used in most of Europe, then there's a meaningful natural zero there. It means 0 floors from the ground. 0 means ground floor. So this would be measured on a ratio scale. But if you're using the Norwegian system where ground floor is 1, then there is no natural zero, and that cannot be a ratio level measurement. Depending on whether distances are well defined, you could have an interval or an ordinal level scale. And of course, you can have negative values on a lot of other kinds of measures. For example, you can have negative pressure, negative force, and lots of other things. So it's not about having or not having negative values. It's about what 0 means. If 0 means no quantity of what you're measuring, then that's a natural 0. Okay, let's now go to another tricky case that actually trips up a lot of people. And it has to do with the results of tests like IQ and other psychometric scales, which actually provide standardized scores. We will talk much more about standardized scores later in this course, and we will learn how to compute them and exactly what they mean. But since we're now on the topic of measuring scales, we might as well clear it up to be able to classify this kind of variable. So, of course, you can say if two people have the same IQ or not. Okay, we have equality or non-equality. And of course, you can say that whether someone has a higher or lower IQ. You can rank all the IQ values from lowest to highest. So there is a natural order in this measurement scale. What about other things? Let's start from the most demanding. Can you say that a person with an IQ of 150 is twice as smart as someone with an IQ of 75? Or does that sound a little silly to say? This actually makes no sense because IQ doesn't have a 0 at all. So there cannot be any ratios there. Okay, what about something a little less demanding? Let's say we have someone who has an IQ of 110. And let's compare this person to someone with an IQ of 100 and someone else with an IQ of 120. Can you say that the person with 110 is as smarter from the person with an IQ of 100 as they're less smart than the person with an IQ of 120? So are these distances interpretable as distances? Can we talk about a 10-point distance in IQ such that different 10-point distances at different points in the scale are actually equal distances? That's the important thing. If they're distances, then they're 10 everywhere. So the distance between 70 and 80 is the same as the distance between 120 and 130. Does this make any sense to say? And the answer is no, because standardized scores don't mean something on a linear scale. Standardized scores are standardized to refer to proportions of the population. So an IQ of 100 means that you have an IQ that is equal to or higher than half of the population. So you're in the middle. You are at 50%. If you have an IQ of 110, it means you're smarter than 3/4 of the population. So you are at 75%. If you have an IQ of 120, it means that you have a higher IQ than 91% of the population. And that's what these numbers are computed to mean. They're set to mean exactly that. So because they refer to proportions of the population and aren't themselves scaled on some kind of linear measuring tape of intelligence, these kinds of psychometric scales are in fact scaled on an ordinal level of measurement. And they're not interval, and they're certainly not ratio. And that limits what we are allowed to do with these scores and how we can formally treat them. Okay, so now let's sum this up. What do the different scales of measurement imply for the variables that we derive? If we start from the bottom, for a variable that is measured on a ratio scale, that we can actually divide and compute ratios, that gives us a quantitative variable, or otherwise known as numeric variable. That means it's a number. For variables measured on an interval scale, which means that we can compute distances but not ratios, that's also a quantitative or numeric variable. It's a number, but it's a number we are allowed to subtract, not a number we're allowed to divide. For variables measured on an ordinal scale, where you can put values in some order, but cannot subtract or divide them, then what we have there is a qualitative variable, otherwise known as a factor variable or categorical variable. It means this variable isn't really composed of numbers, it's composed of labels or codes or words. These aren't numbers. And for a variable that's measured on a nominal scale, where the only thing we can do is to say whether two values are the same or different, of course, there we also have a qualitative variable, or also known as factor or categorical variable. Now, it's important to realize that if you fulfill the conditions for being a ratio variable, so if there is a natural zero that permits meaningful division, then all the conditions above are automatically satisfied. So it's not possible to have a variable where you can apply ratios, but you cannot, for example, do distances or ranking. That doesn't happen. So if you start checking from the bottom, then wherever you stop, the rest is necessarily also going to apply. So if you can rank, then you can check identity. If there is distance, there is also rank, and so on. Let me clarify one terminological thing here, which sometimes confuses people here because of maybe an unfortunate translation issue. So we said that there is quantitative and qualitative variables. And what this means is quantitative is quantities is numbers, and qualitative is qualities is words. And if we look at what these words mean and why this can cause some confusion, quality in the English language, where qualitative comes from, means first, peculiar and essential character, an inherent feature, these kinds of things, which in Norwegian are egenskap. That's the kind of quality we're talking about. Of course, quality also means degree of excellence or superiority, which in Norwegian is kvalitet. Now, unfortunately, qualitative variables and qualitative research are translated in Norwegian as kvalitativ, which makes some people think that we mean high quality variables or high quality research. That's not what we mean. Not at all. It has nothing to do with it. It doesn't mean higher or lower quality because that's not what we're talking about. So qualitative means composed of words rather than of numbers. So quantitative variables are numbers, qualitative variables are words. Quantitative research is research in which we measure things with quantitative variables and mostly deal with numbers, count, compare, and things like that. And qualitative research is research in which we have qualitative variables. We deal with words, with descriptions, with qualities of that sort. Okay, I hope that clears that. And let's also clear up one other point that it's easy to get confused with, because we often use numbers to denote qualitative variables, and that's why you have to think about what the variable means and not what it looks like. So for example, it's possible, and in fact, it's frequent, that when you have a variable like sex, you might choose to code and use the number 1, for example, for females and 2 for males. Or you can choose the other way around. It doesn't make any difference. You just need to be consistent. So then you're going to have a sex variable that has numbers in it, 1 and 2. But obviously, you still cannot subtract those numbers and derive anything meaningful. You still cannot rank those numbers and derive anything meaningful, and you certainly cannot divide them. So they look like numbers, but they aren't really numbers. They're just labels, labels for sex in the form of a digit. You can do the same with education level. So you can have 0 for no education, 1 for grundskole, and so on. These look like numbers. You're going to get a variable with something that looks like numbers, but they're not numbers. They are labels for the categories that have the form of a digit. You still cannot subtract or divide these things. And also, this is not only about a distinction between qualitative and quantitative, because some things that look like numbers may be partially numbers. So in temperature, you actually have numbers. It's a quantitative variable. So you can have 10 degrees and 20 degrees, and you're allowed to subtract them and talk about 10-degree difference. This is meaningful in a temperature measurement, but you still cannot divide them. So what you can do with your values isn't determined by what the values look like. It's determined by what the values mean. And this is why you need to think about the nature of your variable. So there's a lot of things that look like numbers. In this sense, they aren't really numbers in the sense of what you can do with them. Okay, so I hope I've cleared up a number of things that people are sometimes confused by. And now I would like to ask you to try a whole bunch of examples for yourself, or maybe in groups, and apply the criteria of the different operations and classify all these potential variables and more examples of your own into the different measurement scales.